Leetcode 53, maximum subarray. It's a medium type problem, and I would say it's correctly classified, so it's not very easy or very hard. And if you would just take a look to the exemplary solution, like the most optimal solution, then you might notice that it's very simple. By simple, I mean just that it can be written in a very short way, just a couple lines of code. And you may think to yourself that it's such an easy problem that you shouldn't even bother yourself with thinking about it. But I would say on the contrary, because even though the solution might be written in very compact way, there are still a couple of caveats that you may not really pay attention to if you just look at the solution itself. That's why I will try to highlight them once we'll be solving that problem. Yep. And of course, it's like a whole class of similar problems on Leetcode, so definitely something to consider studying on your own. And here is the description. Given an integer array called nums, so as always, first we describe input. We have array, linear data structure with elements inside, and those elements are all integers. And inside Python, you can see, and the type hint is list of ints. Yeah, and the numbers, if you scroll down, there are additional constraints, can be from -10 to the fourth to 10 to the fourth, meaning that both negative and positive are accepted. And because we have to find this maximum subarray, then if they were only positive, you could just sum the whole array and that would be it. But in this case, we have both negative and positive. That's why this problem is meaningful. And additional thing is that there is no constraint on uniqueness, so one number can be repeated any number of times. And we have to find a subarray, and that's our task. Find a subarray, and there are many different like sub collections or sub groups or however you want to call them, from arrays, strings, and so on. And subarray is the most like the simplest one of them, and it's a continuous non-empty sequence of elements within an array. Meaning that, for example, here you have an array. In the first example, you can take 1, -3, and 4 as a subarray, or 1, -3, and 3, 4, and -1 as another subarray, -1, 2, and 1, and so on. Those are all valid subarrays. You cannot have an empty sequence here. It has to be non-empty, so at least single element. You can take the whole array. It also counts as its subarray, but you cannot skip elements. So you could not, for example, take just positives and calculate the maximum subarray like this. Yeah, just take 1 here, then 4, then 2, and so on. Yeah, that's not allowed. And in subsequences, it's allowed, and in subsets, it's allowed. Yeah, so subsets and subsequence generally complicate things, but in this case, it would make this problem easier, even trivial. Yeah, because you would just have to count the positive. But in this case, we have to take subarrays, meaning that we cannot skip elements. And of course, with largest sum, it's already mentioned in the title, or the title hints at it. So we want to take such subarray that once we add all the elements, we will arrive at largest sum. And we have to return that sum. Yeah, so that's our output. We have one output, single number integer, which is our sum. And here is an example: -2, 1, -3, 4, -1, 2, 1, -5, and 4. And the output is 6 because the following subarray 4, -1, 2, and 1 has the largest sum, which is 6. And you can notice that it's mostly positive numbers, but negatives can be as well, because individual 4, look, on both sides have negative neighbors, but on its own is not bigger than 4 plus -1, meaning 3, plus 2, meaning 5, plus 1, meaning 6. Yeah, so together they are bigger than 4 individually, even though 4 itself is the biggest number. Yeah, so sometimes we can also add to our maximum subarray some negative numbers because they are in the vicinity of big or like large, relatively for that particular array, positive numbers. And for example 2, we have just single element. So of course we can have single element as an input, And we can also have, in example 3, the whole array being its maximum subarray. Yeah, so the array itself is its own subarray, which can also be a valid case. So let's copy that. And let's think about, not here. What would be good approach at solving that problem? Maximum subarray. Yeah, and we have already said that we can skip elements, which is the most important thing. So what we can do, however, we can iterate through array, get each number out of our input called nums, and store 2 additional variables. 2 additional variables, current sum and best sum. And current sum is updated or can be chosen between or maybe we can write it like this. There are always 2 options for current sum. Either we reset it to be equal to the new number, so we start a new subarray, or we add number to an existing subarray. Yeah, so increment current by num. And that's it. Let's add arrows to each point, make this a bit bigger so you can see it better. I can either reset, or add to an existing subarray. And because we always have to take the numbers in a continuous manner, meaning that we have to take neighbors together, we cannot skip, as we mentioned here. We have only those 2 options. Either we increment by extending an existing sum, adding the next neighbor, or we reset and we start the next subarray. And for the best sum, it's updated once current sum exceeds its previous value. And that's it. That's the whole algorithm. There is nothing else. We can now try to use it here. So let's store those 2 values. Maybe we can use it. We can create a table and go like this: best sum, current sum, and number called num, and like this. Make 2 columns, 3 columns in fact, and we will iterate through that array And let's start with -2. And so first, or maybe let's start with, okay, well, let's start with -2. Let's do it like this. Yeah, so -2 is the first number. Current sum doesn't have anything, so the best option is at -2, and the best sum so far is -2. Okay. The next number is, let's make it a bit bigger so you can see it better. -2, -2, best sum, current sum, and the next number is 1. And the current sum would be better if we have those two options. So either we can start with 1, or we can add 1 to the previous current sum, and then we would get -1. Yeah, so 1 it's on its own is better than 1 plus -2, meaning that we can start the current sum from this, reset it to 1, and the same for best sum is better than the previous version of best sum. And then we move to -3. -3 on its own is worse than -3 plus 1. So we'll have -3 plus 1. We can even write it like this, equals -2. And -2 is not better than 1, meaning that we still have 1 as our best sum that we have found so far. And the next is 4. Let's do it. 4 on its own is better than 4 plus -2, meaning that's 4, and it's also the best sum that we have found so far. The next is -1. And 4 plus -1 means 4 minus 1 and equals 3. Yeah, and the best sum so far is 4. And the next number is 2. 2 plus 3 is better than 3 itself, so that would be our next current sum. And so 2 plus 3 equals 5, and it's also the best one we found so far. Next one is 1. Let's make it a bit longer, our table. Next one is 1, and 1 plus 5 equals 6. It's better, and here we have 6 as well. Yeah, and then we have -5, -5, -5 on its own is worse than -5 plus 6. And 1. Yeah, and the best sum so far is 6. And the last number is 4. 1 plus 4 is 5. Yeah, and the best sum so far is 6. So that's our output. We have found the best number, and we have to now translate that into Python. So of course we can check first if the array is empty. So if not nonce, then we can return 0, and otherwise we can create our variables current sum and best sum and initialize them to the first element of nums. And then we do our iteration for num in nums. Current sum is the maximum between num and num plus current sum. Yeah, so this is this part. Either we add or we reset it. This is the reset, and this is the increment or addition. And the best sum is max between current best sum and current sum. So the previous version of between previous version of best sum and what we have in the current sum. And that's it. And in the end, we return the best sum. Let's see. From number. Let me check. We have to start from 1 since we have already used the first element. No, like this. One more try. Accepted. And let's see on all the cases. Bit 40%. Let's try again. 28%. Let's think. We can try breaking down the built-ins to if statements. So if num is less than 0, we reset current sum to num, else we do this plus equal num, and if current sum is greater than best sum, then we update, and we will save some updates to the variables in this way. Or it might be a bit faster. Let's see. Let me look. And yeah, I can see it. Not the number, but if the current sum ever goes below 0, then we have to reset. And now we are faster than 95%. Okay, so that's not that clean as the previous solution, not that Pythonic, but it's a bit faster.